Right, what happens? Right, you remember my magnetic gauge in my earlier videos that I made? Basically, it's two magnets each end, back to back, so that I can use it to measure magnetic fields. Now, I need to hold the camera and hold these magnets at the same time because I don't want them to fly away. Now, I've got it one way around. Now, as we all know, a magnetic field is very directional. As I move my gauge towards the magnet, it will be deflected if I have it directly in the middle. Because when I move it to the side, let's move it off screen a minute, and come in from an angle, we have cross field forces. As a result, my gauge is jammed solid because the magnets inside the tube are being twisted. As I move it in front of the magnet, it jumps. That's because the magnetic field is basically directional, and it actually locks the magnet when I move it away to one side. How do we overcome that problem? Because let's face it, if this was a coil passing the magnet, we have a braking effect. We would have a braking effect because we are cutting through the magnetic field. Okay, simple solution, a ball. But this is not what it looks like. It's actually not, it's not a rubber ball, it's actually steel with a rubber coating. So what's the difference between the rubber ball on the end of a magnet? Okay, I'm coming at the magnet head on like we normally do, but we have a much weaker field. But what else do we have? Oh, very interesting. We have omnidirectional magnetic effect, which means I can rotate my gauge all the way around. Oh, let me try and do this. All the way around. Oops, I need to hold it again. And it's not locking. My magnets are not twisting inside the tube and jamming anymore. They are smoothly, easily being moved all the way around the ball. I'm not feeling any stress, any cutting, cross-magnetic cutting at all, because this ball is omnidirectional. Like a microphone is omnidirectional if it's designed to pick up audio from all directions. This omnidirectional effect can be used to our advantage, because if this was actually a rotor and it was passing this ball, we'd actually have less jamming effect. And notice it doesn't jump when I pass the ball. It's actually quite smooth. This makes it possible to have a rotor past a coil or a concentric magnetic field much more easily. And hence we don't lose as much RPM, revolution cycles. But if I remove the ball again, very difficultly, and again I cross the field, it's jamming here. Let's move it off screen, it's coming at an angle. Now let's try crossing this magnet. I feel a huge, what's the word, amount of resistance right here. It wants to go around to the back. like that, because the field is breaking right at this point here. It is jamming right here. But if I go a bit further, if I force it to the middle, that's when we get the push. That's why we need to use the ball. Oh, hang on. That's why we need to use the ball. And like someone on said, balls to you. Anyway, okay. So we can actually solve some problems here. Notice it wasn't jamming. I've got to hold it when I get a certain distance. We have basically, instead of having straight lines, oh, I'm going to mess up my mat now. I need to put some paper down. Hopefully this will be a bit easier. Right, so instead of having fields that are, oh, it's affecting, my pen is affecting the magnet in a straight line, and oops, hang on a minute, where we have these fields like this. Let me get this in. And when we bring our, as our coil approaches here, it is pulling, it is giving us a braking effect, and there's magnetic fields directional straight here. But when we add the ball, what we'll actually do, oh God, I'm fighting with this thing. What we actually do, I'll try and draw this. Let's see if I can find another sheet. If I can get this off. Come on, you bugger! This paper is being awkward with me. Right. I'll fight you with magnets here. Just be patient. Ah! I didn't see that. Magnet. What we actually have with our ball is these fields back here, we can pretty much ignore them because they're being forced back. But our field that we want to tap into, which is the center of the magnet here, becomes omnidirectional, which is what we want to actually capture for our power generation. So we have an omnidirectional field here, which is equal, or even spread out more, and it's actually weaker, obviously, but we're actually in that field longer. So, just a minute, I'm trying to get my gauge off here. Right, let's put the magnet and the ball back. So what we're actually doing is we're overcoming that braking, that, you know, that effect we had when we got to the side where it was really jamming up. Actually, my ball's not on right. It's not as bad as it was before. It's much smoother, as you can see. We can come at it from a different angle. I'm in the light now. But we couldn't have done that before. We can't do that without the ball. Because if I take the ball off, it's, as I say, it's an iron ball with a rubber coating. I could take the ball off. It's jamming again. It's pushing a bit, but I'm feeling it jamming. I mean, oops. Right, I think you get the idea anyway. Okay, 10 minutes. I want to keep the videos down to 10 if I can. Still fighting. Oh, thanks for watching.